Here we go. So welcome to London DevOps. London DevOps number 58, first one in 2021. So about London DevOps, we're here to share knowledge, meet new people, help each other out. So we've got a couple of good talks going on tonight. So we're going to learn lots about GCP. For those of you who don't know much about it, I count myself amongst those people. I've been AWS through and through since about 2009 and not really dabbled on that side. So I'm looking forward to hearing more about GCP. So yeah, hopefully it'll be entertaining for everybody. Yeah, we're recording, or we are now, and everything you hear here is shareable unless somebody says that you shouldn't. We haven't actually had that yet in any meetups. That's why, if you brings enough controversy to say, please don't pass this on. Or maybe it's just because we're on the virtual meetups that everyone knows everything's being recorded. Talking to things being recorded, there's our YouTube channel. If you stick London DevOps into YouTube, you'll find us. Pretty much every meetup that we've had is up there now. So stuff going back all the way to 2014 now, a big library of things, culture talks, process talks, and tech talks as well around DevOps. So please do go and look that up later on if you want to. Code of conduct, this is something we take very seriously. That is the code of conduct for the meetup. Obviously much more important when we're physically co-located, we're in a meeting room or some event space, but it still applies. You know, people still can do things that we don't want you to over Zoom. So please don't. That's the code of conduct. I know we're all good and we're all nice and we'll have a nice time. So let me just leave that on the screen for a minute before we move on. So London DevOps came together many years ago, in fact, but in its current incarnation, it was founded by Mark, who is here. Mark, do you want to say hello?
Hello, everyone, and welcome to month 14 of 2020.
Nice lighting, dude. I haven't seen that before. That's really nice.
Yeah, I have way too much time in my hands now.
Yeah, don't we all? Don't we all? So yes, we're all here thanks to Mark picking up the group in 2014. So Mark's still one of the organisers. Here are all four of the organisers. So I'm the second one. So I'm not wearing that t-shirt today. I'm wearing this one. Yes, so I'm here as well. Jack, do you want to say hello?
Hi everyone. Thanks for sharing your evening with us.
Cool. Thanks, Jack. And finally, the fourth organiser, Alex. Say hello, Alex.
Hi guys, Alex here. Hope you're good.
Cool. Well, that was nice and brief and concise. That's good. So yeah, so we are your organisers. If you're here for the first time, then yeah, I'm generally the one who stands up here making a noise, but I can't do this without the whole team. So if you want to speak, if you have any comments on the meetup or anything really, just want to chat, then drop one of us a line. Those are our Twitter handles, you can see, but you can also contact us via the meetup page if you want. Talking of contacting, let's send out some tweets about what's going on tonight, get some discussion going on there. There's the hashtag London DevOps. Let's move on to sponsors. So it's easier in the virtual world because we don't have to organise venues and pizzas and beers and drinks and stuff. But we couldn't really do this without some sponsorship in terms of time and effort from the organisers and their associates, and also some money sometimes. So let's just run through the sponsors quickly. So firstly, we're sponsored by Prism Digital. So Alex, that's Alex's company. Alex, do you want to say a few words about Prism?
Yeah, sure. So we're a talent partner operating within the DevOps and cloud space. So happy to work with both people on a we can find you DevOps people basis, or if you're a DevOps person looking to find a home somewhere else, we can help get you project opportunities, introduce you to some cool clients that we work with. So yeah, DevOps and Cloud Talent Partner. Yeah, we're here. I'm here. If you want to talk about anything about the market, feel free to reach out.
Great, thank you, Alex. Cool, so moving on. So Adaptivist also sponsored the event. That's generally allow me some time to arrange and host and all that sort of stuff. But Adaptivist is quite a large company now. Actually, I'm going to say a small company, but we're quite big, 400 odd people, starting out through doing Atlassian things, so helping people with Jira, Confluence. We own and run the biggest Jira plugin, the most popular one, Script Runner. Do lots of other plugins and products around Atlassian, and also services. So helping people to get their Atlassian state working well, either in data center or in the cloud. And we're starting to branch out into other areas, such as doing things with the likes of Sonatype and GitLab, all that sort of good stuff. Quite a few adaptivists on the call as well, so thank you very much for coming along. Good to see you. All right, moving on. So WeShape as well is the final big sponsor. Jack, if you're not busy with Ada, did you want to say hello and say a little bit about?
Yeah, no, thanks. I'll just warn you, but my 2-year-old daughter might jump on the call as well, so just to prepare everyone for that. But yeah, WeShapes, we're a technology consultancy, kind of focusing in the DevOps space. I suppose we work with customers from kind of technical and business advisory all the way down to project implementation. So mainly with kind of squad teams and on-demand consultants, but we do training and coaching as well. But yeah, it's great to be a part of this part of this group, and we are recruiting at the moment for DevOps engineers for permanent and for contractors. So if you want to learn more about working at WeShape and working on some of the projects that we're currently involved with, yeah, drop me a line. But yeah, thanks. Cool.
Thank you very much, Jack. Cool. All right. So that's about it for the intro. Let's talk about the talks. So first up, we're going to have Phil, who's going to do a little intro on Google Cloud and not only what it is, but some of the things to watch out for, things that should be interesting to people who are more familiar with perhaps AWS, etc. So we're going to have a story so far from Phil on that, and then we're going to move on to Natalie, who's going to tell us some hopefully entertaining but possibly not so good stuff around the misadventures of one cloud function. So those are our two talks tonight. So we'll get on with those in a second. Before we do that, I just want to say thank you to you. Thank you to everyone for coming. So yeah, we'll have the two talks. I'll leave the Zoom open at the end for anyone who wants to stick around for a mini social. Not the same as going down the pub, but what can you do? But otherwise, yes, please do tell us what you think through one of those mechanisms, or get in touch with us by email or Twitter, whatever. That'd be great to see. Let's just check the chat. Love a bit of toast. Yeah. Yes. DevOps is love, most definitely. Anything else to pull out there? Yeah, thanks to everyone for introducing themselves. Brilliant. Brilliant British accent. Thank you very much. I'm related to the Queen, don't you know? Not really. Okay, cool. So that's it. That's it in terms of the intro. Let me stop the share now. And Mr. Wigg, if you wanted to start sharing, we'll see if we can get that show on the road.
Okay, let me have a try.
Yeah, really looking forward to this one.
Me too.
Gosh, that's pressure. Yeah.
Yeah, no pressure.
Yeah, no pressure. No pressure. Just be here.
Okay. All right then. Well, in that case, it's over to you, Phil.
Thank you. So can you all hear me okay? So you all see the slides? Yeah, good.
Yes.
So
yes.
welcome to my talk then, which is an introduction to Google Cloud. So before we start, I was going to try and do some bit of audience participation. So are there people on this call that have never used Google Cloud before? So can you kind of give me a wave or do something? Okay, yeah. So I'm going to pretend there's a room full of people, and I can see about 75 of you maybe waving back because you've never used Google Cloud. But I guess many of you will have used AWS. So what I'm going to do, we're going to do a short history of Google Cloud, so how we got to where we are today. And we're going to do a demo of Google Cloud, and I'm going to just show a couple of the features that I thought were interesting coming from an AWS background when I first started using GCP. So another thing is I'm going to just keep using the terms Google Cloud and GCP interchangeably. So they're exactly the same thing. I just happen to say one or the other depending on the sentence. So we're going to do about 10 minutes of Google Cloud history and about 10 minutes of a live demo, a bit more history, and then we'll do a final live demo. So who am I? So my name's Phil Wigg. So I've been a DevOps engineer, cloud engineer, and engineering manager for more years than I want to count. I now run a small cloud consultancy called MakeCloud, which focuses on GCP. So if you're interested in Google Cloud, which hopefully you are if you're coming to this talk, then add us on Twitter or LinkedIn, whichever you like. So where are we today? So you probably already know that we've got three major players in the public cloud space. So we've got AWS right out in front, and then trailing that is Microsoft with Azure, and then lagging in third place is GCP. So how did we get here? Why are tech giants like Google and Microsoft behind in market share against an online bookstore? How did we get to this place? So public cloud has existed now for about 15 years. So there's probably some of you out watching, especially if you're early in your careers. So you might not remember how public cloud started or what the events were that led to it starting. So I'm just going to take a quick minute just to take us all back in time to what I call the beginning of episode 1.
Sorry.
Yeah, this is before Baby Yoda for anyone that is onto the new stuff.
So what did we learn? So basically Amazon invented AWS because it invented it essentially for itself. So it needed a composable set of services to run Amazon, the bookstore. And once they built it, they realized that essentially running infrastructure had become a core competency of Amazon, and that they needed actually they were able actually to sell it to other people. So once they started on AWS, they they launched all of these services between these 2 years. So it was incredible really how fast they launched these building blocks of the core infrastructure as a service products like EC2, RDS, S3, which still really form the backbone of AWS today. So by 2012, they've already had the first reInvent conference. So they've got 6,000 DevOps developers, IT professionals in Las Vegas. And basically AWS as we know it is now fully formed, it's up and running. So what have Google been doing during this time? So the important thing to say, I guess, is that they do launch some cloud products. So this is the blog post introducing the first cloud product Google ever launches, which is called App Engine. So it's a platform as a service product. So you write your web application code, you give your code to App Engine, and it hosts your website for you on the internet. But it's interesting to see how Google pitches this. So they pitch it very much as a developer tool. So it's not really aimed at business. And it's clear that Google are kind of experimenting to see what works. Do they get any traction? And in fact, App Engine doesn't actually become generally available for another 3.5 years. So they do launch storage as a competitor to S3, but it's kind of the reason they launch it really is to tie in with App Engine and the other product that they've launched called BigQuery. So you've probably heard of BigQuery. So it was groundbreaking data warehouse. So businesses could analyze, process huge amounts of data, and they only pay per database query. So that's actually a really popular product, and it serves a particular niche. But there's no way you can do what you can do with AWS, which is basically turn all your servers off in your data center and fully move to the cloud. So it's not until the end of 2013 that they launch Compute Engine. So Compute Engine is essentially EC2, but it's not until 2015 that Compute Engine even supports Windows. So around this time, 2015, 2016, they launch their other kind of IaaS products. So they launch managed databases, load balancers, message queuing, and around those years, you can say that GCP now has the products they need to support a migration out of a data center and into GCP fully. So technically now it's kind of a competitor to AWS, but it doesn't stop. But that first mover advantage is really why AWS is so far ahead today. But it's not really the reason that Google is in third place. So there's another reason, which is for a long time they were basically terrible at selling to enterprise customers. So I'll talk about that a bit more later. So where is Google Cloud in 2021? So before we get into a demo of GCP, I thought it would be good just to see what products it currently has. So I won't spend too long going over every one because we have 90 products now, but here are some of them. So App Engine we've talked about is platform as a service. So basically Elastic Beanstalk. Cloud Functions is serverless functions, so Lambda. Compute Engine is EC2. You can run Google Kubernetes on premise. You can run Kubernetes GKE clusters. Very strong on data analytics, so BigQuery that we talked about. Managed Hadoop. Message queuing is PubSub. Databases, so we have column databases, document databases, SQL databases. Basically, for every AWS product, there's generally a GCP equivalent. So security, you can scan containers, you can get warnings about firewall rules with various IAM. AI and machine learning, they're very strong here. So too many to talk about. Various management tools, so what's a good one? Logging, Stackdriver, monitoring, etc. And then networking, all the same sort of networking, so web application firewalls, CDNs, VPCs, etc. Various developer tools that they have, so they've got their own CI/CD, their own source control. So yeah, so let's just dive in and do a quick demo. So can you all see the Google Cloud Console now? Someone give me a wave. Yeah.
Yes.
So this is the first page you see when you start the console. So AWS has this concept of accounts. So you've all, I'm sure, owned lots of AWS accounts. So instead of AWS accounts, GCP has projects. So basically all these guys down here, the ones with the 3 little dots, are all different projects. So I'll just dive into a project to show an example. So in much the same way that an AWS account contains resources, in GCP projects contain resources. So compute instances live in a project, storage buckets live in a project, everything basically lives in a project. But you'll notice that there's this hierarchy here that you can see, that's the organization at the top, and then there's a level above projects. So these are folders. So folders are logical, basically just a logical group of projects. So folders don't contain any resources, so you can't deploy an instance into a folder, but you can set permissions at the folder level. So if I was to set, let's find one with 2. So if I was to set I am policy here that I am a storage admin, then that I am policy would propagate down into the projects underneath, and I'd be storage admins on both of these projects and any new projects that are created. So one thing to note about GCP as well is in AWS, your IAM user is contained within a specific account. So if you want to access something in another account, you're looking at cross-account role, assuming a role in another account essentially. So in GCP, it's different in that your identity, your account, lives in G Suite or Google Workspaces as it's now called. So your IAM user is independent of any specific project. So it means you can create a project and delete a project, and you can access it here. So it's much easier and much more normal to kind of swap between projects in GCP, I found, than it is in AWS. So what I want to do for my demo is create a project and create a couple of compute instances and talk a bit about networking. But because we're London DevOps, I'm not going to create things in the console. So I'm just going to swap into IDE. So Google gives you this thing called the Cloud Shell Editor, which is like a web-based IDE. So I'm just going to use it for this demo so that I'm in the browser, basically. I don't have to keep swapping back to code. Hopefully it'll wake up soon. So what I've done is I've written a little bit of Terraform that we're going to run. So what the Terraform is going to create is, first of all, we're going to create a project. So like I said, project is basically like an AWS account. It's going to be called London DevOps with a little random GUID on the end. And it's going to be housed in the folder that we saw, which is called London DevOps as well. So in addition to the project, we're going to create one compute instance in London. And if you notice, there's a parameter that specifies where the compute instance is going to be created. And that value is an output of this module up here. So basically this compute instance is going to get created in this project. And then we're going to create a separate compute instance in Australia. So that's going to be in the same project as well. So 2 identical instances, one in London, one in Australia in a new project. So I'm just going to see if this actually works, which would be amazing if it does. Okay. So while we're waiting for that to apply, I'm just going to talk a little bit more about networking. So if you're coming from an AWS background, then you're probably quite used to this this screenshot. So this is a typical deployment of some VPCs and some subnets. So a VPC in AWS lives in a region. So it could be EU West 1 in Ireland, you'll have a network. And then your subnets are limited to a single availability zone. So you subnet across availability zones, and usually you'll create more than one subnet. You'll create public subnets and private subnets. So it's quite a common thing to do. So in Google Cloud, it's a little bit different. So I'll drop back to my project that's got a VPC in it and just have a look at a VPC. So in Google Cloud, this is a subnet here. This one called this is a VPC. Sorry, this VPC is called default. So, as you might guess, it's a VPC that's created automatically when you provision a project. It's the default VPC. So basically the same. You've got a default VPC in AWS, but what it does as well, it creates a subnet, single subnet in each region. So in GCP, this main difference is that subnets are regional, so you don't need to limit your subnet just to one availability zone, and your VPC actually is global. So if you want two instances to talk to each other, despite the fact they're in different regions, then that just works. You don't need to worry about inter-region peering or VPNs or whatever you need to do on AWS. So another cool feature of GCP is that you can deploy a VPC, say in this project, and you can designate it as a shared VPC, and then you can deploy from other projects into that shared VPC. So it means that you can have an administrative boundary between here and here. So your network team can manage the project that has the VPC in it. So they control firewall rules or whatever routing, whatever it is. And then people that want to deploy into the network can do that if they have permissions, but they don't get to change firewall rules and stuff. So it's a way of establishing that separation of duties. So I'll just see if that finished. I think it did, because I think I just saw my project. Yeah, cool. So just go into my project. So this is the project that we just created. Hopefully we can see our two VMs. Yeah, there they are in different regions. So I'll go back into the console again. So I'm just going to start a new shell in the context of that project that we just created, so I don't have to keep keep specifying the project on the command line. See if we can check we can see them. Oh. It's a bit slow. So one thing in GCP is that in AWS at this point, if you wanted to SSH to these instances that you've just created, you'd probably be setting up bastion hosts or opening up firewall rules or whatever. So in GCP, it handles it all with the G-Cloud tool using tunneling. So what I can do is just go to here, and I just need to tell it what zone it's in. So again, SSH, you don't need to worry about SSH keys in the same way that you do on AWS, because what it's doing at the moment is it's taking my SSH key from my Cloud shell, it's uploading it to the project metadata of the project that we just created. So projects have some metadata, and then the VM itself reads that metadata from the project, adds my SSH key because I'm authenticated. I've got the right permissions on that project, and I can just SSH in. So hopefully, because as we said, VPCs are global, I can use this DNS convention. And then from our VM in London, we can ping our VM in Australia. So yeah, that's our demo. I mean, it still amazes me that little bit of Terraform there can create this project global network, and then the two instances that can talk to each other over the internal network. So because the way that projects are managed makes it easy. Projects are very much cattle, not pets. So we can just destroy our project again if we want. Oh, am I in the wrong folder? Yeah, I am. and it's gone. So I don't think there's too many people that are creating and destroying their AWS accounts in that way. Okay, let's see if I can't see my tabs anymore. So I'm going to carry on a bit with the history of GCP. So just to recap, we're now in 2016. Google is technically its a rival to AWS, but Google is still selling, struggling to sell to enterprise customers. And why is that? Basically, it's because the Google Cloud sales pitch is, we are Google, we have amazing data centers, world-beating global network, we serve billions of requests every day. Google Cloud allows you to run your applications on the same infrastructure that Google uses. And that's basically the whole pitch. So they're basically assuming that the technology will sell itself, and they don't put a lot of effort into sales or marketing, and they certainly don't have the same sort of anything like the same sort of enterprise sales organization that, for example, Microsoft does or Amazon. So they get a new CEO, this lady called Diane Green. She's actually the co-founder of VMware. And she's obviously used to selling to enterprises, and she recognizes the problem, but it seems like for some reason she's not successful in actually changing very much. It seems like there's some internal politics in Google maybe at that point. So she leaves at 2018. 2018 we get a new CEO called Thomas Kurian, and he's come from Oracle. He has 22 years experience at Oracle. So Oracle, as some of you have probably experienced, is great at selling into enterprises. And he immediately makes quite large changes in the way that GCP sells to enterprise customers. So what he does essentially is he divides the sales division into industry verticals. So manufacturing, healthcare, media. And what that means is that if you're a retailer and you're asked to speak to Google Cloud Sales, they don't tell you how you can run your applications on Google's infrastructure and be amazing like Google. They talk instead about specific challenges retailers face and how Google Cloud can help you solve those challenges. And that account manager that you speak to only deals with other retailers, so he understands basically your business. And the other thing Thomas Kurian does is really build out the sales organization and add many more people that can talk to enterprise customers, and they're still hiring like crazy today, actually. So the strategy seems to be bearing fruit because revenues increased 47% year on year. They're actually losing a stonking amount of money, but I think what we have to understand is that we're in the really early days, I think, of cloud computing. So the global cloud computing market is expected to grow from $371 billion at the moment to $832 billion in 2025. So who knows where that will be in 2030. So there's much more money to be made and much more market share to be gained. So to go back to the Star Wars analogy, I think we're about halfway through episode 1 at the moment, with many more episodes to come. So I'm going to do one more demo. So you probably have a few Kubernetes fanboys here, I would imagine. Google Google was the one that gave Kubernetes to the community. So we're going to quickly look at Google Kubernetes Engine, and specifically a new product that they've launched called Anthos. Okay, so I'm going to change into a project GKE demo. And clusters. So what I've done in this project is I've created 3 Kubernetes clusters, and you can probably see that one of them looks a bit different. This one here is an Anthos cluster. So we'll just take a look at if it's running anything. So there's no workloads actually, there's nothing actually deployed to this GKE cluster at the moment. So we'll go and fix that. So Google has this microservices demo repo, which is quite handy if you ever want something to just spin up basically on a GKE cluster. So what it is, it's an online boutique, and it has about 10 microservices that it deploys for email and front end and email and payments and various. So it basically simulates a little microservices app. So what I'm going to do is see if I can deploy this to our cluster. Typical. Okay, that's not working. That's a bit annoying. Just let me get this into here. Okay, I might have to give up on this. I'll just have one more go, I suppose. Hold on.
Yeah, it's all right. The demo guards are never merciful.
I've done this about 20 times today, and it's always just gone without a hitch. So let's just see if it maybe is just Chrome. Okay, come on, Cloud Shell.
You've used up your demo credits with those 20 attempts. That's what it is.
Well, I was nervous about that actually, because there is some sort of quota. So I did wonder if that might have been what's happening. Okay. Come on. Well, hey, I think we're back. Right, how do I get the editor? Hooray, okay. Oh, I never pressed yes. Okay. So I just check I can connect to this cluster. Yes, I can. Okay. So I've got the YAML for that demo here. So I'm just going to apply it. Great. Okay. So while that's applying, I'm just going to talk about another challenge that enterprises have. So basically, enterprises tend to have large legacy estate, which isn't suitable for moving immediately to the public cloud. And they often have capital investments in server hardware. So they've basically got a bunch of servers, or they've got networking equipment. They might have a rack spaces leased. So they might have 3-4 years of racks at some on-prem data center somewhere that they don't want to just throw all that away when they move to the cloud. So what they want to be able to do essentially is modernize in place and make it easy for them to move to the cloud when you're ready. And that's what Anthos allows you to do, is run a Google Kubernetes cluster either on your on-premise network, or it could even be in another cloud, and use the same control plane and the same set of APIs to manage that Kubernetes cluster. But it could actually not really care where it's running, because that's abstracted away from you. So we'll just go back to our cluster if that still works. So go back to cluster 2, and we'll see if we've got our deployments yet. So we can see all those deployments that I just applied are all there. And then if we look in services and ingress, we'll see we've got a external load balancer as well. So let's just have a look if that works as well. So we've got our shopping application that we've deployed. So we can start buying typewriters if we want. So in case anyone hasn't guessed it yet, the big reveal is that actually that cluster isn't running in Google Cloud. It's actually running in AWS. So it's an Anthos cluster. So there's our node pool that matches, those nodes there are these nodes here, and that load balancer that we were looking at in a services and ingress is a AWS load balancer down here. In fact, it's that top one there, and that's what Anthos allows you to do. And apparently, it's really popular. They're selling a lot of it at the moment. And AWS has announced their competing product, their EKS Anywhere, which is coming out in 2021. So yeah, that's the end of my demo. Yeah. So yeah, if you've got any questions about GCP, feel free to contact me, email me, add me on LinkedIn. Always like to talk about GCP.
Good stuff. Thank you, Phil. Okay, you up for a couple of questions?
Yeah, sure.
Cool. There's just been so much chat. Apologies if I forget anything. All sorts of deviations around. People talking about demon internet and the floor caving in due to too many servers, and God knows how we got there. But just pull out some questions. There's one from Danu who's curious about the costs in GCP compared to AWS. Do you have a short answer on that one at all?
Bloody hell. So I was in a meeting not that long ago with a senior finance person at a large corporation, and he was saying, which is cheaper, just which is cheaper. And I use the example of storage. So even with the most basic product like storage, you pay to upload, you pay to list, you pay to download, you pay different amounts to transfer between regions. There's different tiers of storage. So they make, I think, somewhat deliberately, it very hard to compare apples with apples when it comes to costs. So the rumor on the internet is that GCP is a bit cheaper for compute, but it's really hard to say. There's no noticeable differences. And as with everything with cloud, it's what you do with it that counts as well. So you're going to save your money by turning it off when you're not using it. Essentially, that's the difference to focus on, I'd say.
Okay, cool. So follow on from that, Marius is asking what's the price for Anthos. I'm guessing that's not a simple answer either, but anything you can add to that?
The answer is I don't know. So for Anthos on AWS is a variation of Anthos on-prem. So there's Anthos on bare metal. So I think that it's list priced on the website, but I don't know how much it is, I'm afraid.
Okay, cool. So Ravi's asking about, so in Amazon, we're used to using RDS, relational databases, Postgres, Cassandra, MySQL, etc. Is everything BigQuery over in GCP world, or is there something more familiar over there?
No, it goes back to basically these guys here. I don't know if can you still see my screen?
Yeah.
Yeah. So for databases, it's these. So data store and file store are basically DynamoDB. Cloud SQL is basically RDS, so that's managed Postgres, MySQL, or Microsoft SQL. Spanner is some sort of global relational database, and Bigtable is a giant column database. So I think this one is the one. I'm not sure Amazon has a competitor to Cloud Spanner, and I know Cloud Spanner is really expensive. So for most people, it's RDS is Cloud SQL, and DynamoDB is this guy now.
Fabulous, thank you. John Buero, apart from the trolling, which I might forgive you for, did you want to come off mute and ask a question about ephemeral VMs? I can't quite.
Sure, yeah, can you hear me all right?
I can, yeah.
So one of the things I love about GCP is ephemeral VM. So if I have a demo environment like this, I can just stand up, at almost no cost, and then not worry about it if I forget to turn it off because it'll be gone. But sometimes it may last 10 minutes, it may last 2 hours. What can you tell me about ephemeral VMs?
So you mean like the equivalent of AWS Spot instances?
Yeah, similar, right? So it's deprioritized and it could be reclaimed at any time, right?
Right, yeah. So GCP has what they call preemptable VMs, which is basically the same as Spot instances. So they can be reclaimed at any time, and I think they've got a maximum lifespan of 24 hours. So it's to all intents and purposes very similar to Spot instances. So you can run them on GCP GKE clusters even, or data analytics clusters. So if you've got a Hadoop job or a Spark job, I think you can have preemptables as nodes for those as well. So yeah, and they're very cheap. I think they're about 80% of the cost, 20% of the cost, or something like that.
Yeah.
Cool. Thank you, Phil. Thank you, John. Dominic, did you want to ask a question?
No, this is fine. I was just going to ask you how you were doing.
Yeah, fine, thanks. Yeah, good.
That was a very British answer. Can't complain. I have the same one.
Well, I mean,
okay, brilliant. Okay, everyone, if you want to just come off mute very, very briefly, just to give Phil a round of applause. We say thank you very much for that excellent presentation, excellent demo. That's it. Thank you.
Thank you, guys.
Thank you.
Thank you, Phil.
Thank you.
Good stuff. That never quite works as well on Zoom as it does in real life, but hey, we've got to try.
By the way, while we're changing speakers, I just wanted to say that Mr. Glenn Wilson, who is an old school chap from London DevOps, he just published a book, and it's about DevSecOps. And I have it. It's quite interesting. So I dropped the Amazon link. I don't get any commission, by the way. I dropped the Amazon link in the chat if anyone's interested to know more about DevSecOps.
These guys are producing secure software without compromising flow feedback and continuous improvement. It's impossible, surely. I need to buy that. Cool. Thank you, Mark. Yes, and yeah, thanks, Glenn. That's yeah, that looks awesome. Yeah, so I'm just going to read this now. No, I'm only joking. Right, so let's move on. So thank you very much, Phil. That was brilliant. We're going to move into the second speaker tonight, who is Natalie. Are you there, Natalie?
I am here. Hello, everyone.
Yeah.
Very excited to be here. And actually, I will entertain the demo gods quite a bit. So Philip's presentation really set the base for mine as well. And before we begin, let's just introduce the hero of the story, the Cloud function. So what I have here is a little bit of Terraform. For anyone not familiar, Terraform just describes your resources and then state, as we saw in the previous demo, just deploys and creates the resources that you described. Do you see my screen?
Yes.
So we create a little project, a little storage bucket where we will host the code for the Cloud function, but also use it as a triggering event for the Cloud function. We deploy the Cloud function itself, create a service account for it to run as the identity of the Cloud function, and we create a little security perimeter. More on that later. Let's go ahead and try to apply it. Now I have pre-created some of the resources for the sake of speed of it. So what we should see here is just the Cloud Function itself. There we go. There it is. Okay. Yes. Now we will see it try to apply and fail. And that is the reason why this talk exists. I want to show you what happens when you try to create a Cloud Function in a very secure perimeter. We're working with sensitive data, we're working with business analytics and business critical data, so we really want to secure our environment. But then we try to deploy something and it fails with Vbc Service Controls. Now, I know how to fix it, and I will launch a deployment of something else that will enable us to fix this unfortunate issue. And while it plans, we can go to the Cloud Console, to the logging part of it. If you've never used the console, just type something that you're looking for in the search bar and it will show you all of the resources, really handy. So last 30 seconds, there was nothing in there. Okay, great. We will see the error that appeared. Here it is, Vbc Service Controls. Every time, like if you work with security perimeters, every time you have an error, it will show up in the source project of the originator of the error as Vbc Service Controls. So you can really find it and look for it. So this will be applying now, and we see that the function tried to deploy, but then its identity did not pass the security perimeter. And now that we have the background for the story, hi properly this time. I am Natalie Godec. I'm a platform engineer at Babylon Health. We are an amazing company trying to deliver accessible and affordable health service into the hands of every single person on Earth. And like any company trying to revolutionize the world, we need a really good data platform. And with all of the tools available in the industry, with all the cloud providers making sure that we have all of the tools for every single task we can imagine, we can really tap into the potential and harvest all of the data that is floating around. You might have your application events and your log streams, your user data, user behavior, web analytics, app analytics, and so much more. Like any trend that is going on the planet, you can really harvest it if you have a really good data platform and use it to your advantage. If you choose to use GCP as your data platform, you might have something like this. You might have your app events in Kafka, and they get picked up by Google Dataflow, poured into BigQuery or Google Storage. And then once you have all of your data in those areas, you can plug all of your tools that are for transformation, that are for data analysis, visualization. You can plug ML pipelines and AI in notebooks and do data modeling on it. Or if you don't need something as advanced and as complex as that, someone is not on mute, please go on mute. Thank you. If you don't need something really complex for your data transformations or for some certain more lightweight workflows, you might want to use serverless, such as Cloud Functions. Cloud Functions allow you to run your code on a platform that is completely abstracted from its infrastructure. You will never need to think about where the code runs and how it is deployed, how it is compiled, how the infrastructure works. You just focus on developing your application and deploying it to the cloud. Many of you have posted in the chat that you are familiar with AWS. Lambda is your Cloud Function. Cloud Functions reply to events, so it's same as Lambda do. And sometimes it's an event from PubSub or something like that. Or you might want to have a scenario where someone puts a file into a storage bucket. It might be your third-party data providers if you're waiting for some data from, let's say, web analytics tools. It might be just some user uploading a file into your platform, into a storage bucket, and then you want to do something based on that event. A Cloud Function can listen to that bucket and listen to specific files that you define in the code of the function itself, and then do the things that you want it to do. The good thing about using a serverless platform is that it integrates really well with all of the rest of the APIs. So if you need to do something, to write something in a database based on an event of a file arriving into the storage bucket, you can do that. Maybe your data is something that you want to write in a BigQuery table, you can do that. You can call into PubSub for some notifications, or even call another cloud function if you want to have a more modular, more segregated approach to your workflow. This is really good for security. But you might say that all of those things are public APIs. Everything in the cloud is a public API. Every resource that you have is just another endpoint to a public API. So how do you secure that? How do you make sure that your business critical data is not intercepted in transit, that it's not hacked into, that it's not accessible by people who really want to do harm to you? Well, Google took care of that with Vbc Service Controls. That error that we saw at the beginning when we tried to deploy the cloud function and it didn't work, well, that was Vbc Service Controls. This service allows you to create a security perimeter around your resources, around your APIs. And you do that by listing the APIs you want to protect. And if you're working with data, you might want to include storage, BigQuery, Dataflow, cloud functions, for example. And you list the projects that you want to protect within this security perimeter. The proper term for it is service perimeter. And then the requests that go to those resources will not go to the public API anymore. They will physically not go to bigquery.googleapis.com. They will go to restricted.googleapis.com. That special DNS address resolves to 4 or 5 different IP addresses and is a designated area for your restricted services. And so any identity that is not explicitly allowed to traverse the perimeter will just not be able to find your resource and just not be able to reach it. So you might want to say that maybe only specific users or specific service accounts can access the data or the APIs that you want to protect. You might want to say that only people connected to the VPN can access it. Or you might specify regions or device conditions and really identify the people or the processes that can access your data or your APIs, your services, and no one else will be able to. But then why did we fail the deployment of the cloud function? If the API of the cloud function is in the restricted googleapis.com, as well as the other APIs that we protect, but they reside in the project that is also protected. So why did the deployment fail? Like it should, we managed to create the storage bucket just fine. So why did cloud function not work? That's because Google uses a lot of things that happen in the background. We call them shadow projects. It's processes that run in a space that is not your Google project. Your resources exist in the project that you see and you can manage, but there is also stuff coming up in the background where you cannot access and you cannot manage it and you don't see it. For cloud functions, Cloud Build is such shadow service. Cloud Build will take the code of your cloud function and compile it into an executable container. That process runs as a specific Cloud Build service account, which is unique per project, so it only can access resources in your project. It's assigned to it, so it's still secure, but it doesn't reside within your project, so it doesn't reside within your service perimeter. And that's why that process failed. That's why we saw an error in deploying the cloud function. So now if we go back, we again saw this error. We changed the service controls of this service perimeter. I've added an access level. This access level has several service accounts. Service accounts are your robot identities, your robot users. And we can see that there is the Cloud Build service account in here. And that's what builds your cloud function. You also see a GCP-SA-cloud build, which is a less documented one. But while we were trying to make cloud functions work within service perimeters, we found that this service account exists. So we also added to the access level to deploy cloud functions. There are other two service accounts, which I will describe in a second. But basically what I did, I defined an access level, an identity that lists 4 service accounts that will be allowed to traverse my service perimeter. I added them here, and I applied this change. The reason why you see an error here still is because cloud APIs are eventually consistent. And while I run Terraform apply again, I will explain that. When you change something in this security perimeter, when you add an identity or add a project, add something to it or change something in it, that change is not applied immediately, unfortunately. It takes anything between like a couple of minutes to about half an hour in our experience to apply that change. So that's why I did it in the beginning, and now there's been a couple of minutes, so the cloud function will hopefully be able to create. And we will go into the logging console again and hopefully watch it create the cloud function. The logging in GCP is really good. You have by default so much information about what's going on, and it's all here. It's all really easily accessed, really easily queried, using keywords, using strings, text. It's very intuitive, and most importantly, you don't have to set it up. It's just there. So we can see that there's stuff happening. This is the cloud build actually running the build, compiling the code that you have into the executable container. And we see here that it's being deployed. There's still Vbc Service Controls errors, despite there's been a couple of minutes since we applied the change to the service perimeter. But we can see that there's a container that has been pushed. This is still creating. Fingers crossed, the demo gods are on our side. Yeah, push, done. Cloud build finished, upload of an executable container. GCF, see, Google Cloud Functions. And if we go into the Google Cloud Functions console, which is again accessible if you type Cloud Function, here you can see Cloud Functions. And we update this. There it is, and it's green. It's been created. We didn't have an error anymore, and Terraform applied successfully because we have allowed the cloud build service account to traverse the security perimeter. Before it wasn't allowed, so the request just failed. And that assures you that your data will not be exfiltrated or lost while you're using a security perimeter. Now let's try something else. Let's try to upload a file into this bucket that I mentioned before, where the cloud function subscribes to that bucket. I believe it's somewhere in my history. The name of the file is not random. I have written in the code of the function that it will listen to this particular file. So let's just upload that. And in a couple of minutes, we can watch in the logs that in a couple of minutes, it will have triggered the function. While that's happening, I mentioned that all of your errors for Vbc Service Controls will have this Vbc Service Controls tag on them. And I mentioned that we have 2 more service accounts in this access level that are not cloud-built service accounts. Now, these are the runtime service accounts for this cloud function. One of them is the one that I create right here. And it is a generally good practice to create your own service account and assign it to the cloud function. That way, the identity and the permissions that the cloud function has are restricted to only what you design. Like, I'm giving it storage admin, and that's all it needs on this particular bucket. That's all it needs. And that's even if someone manages to hijack into your function, that's all that they will be able to do, access this bucket, nothing else. So it's a really good practice from the security perspective, because if you don't do this, then the default service account under which the cloud function runs is the default compute account, which has editor on your project. Depending on your scenario and depending on your environment, that's really not desirable. So it's really good to create your own service account. That's what we're allowing here. And then this guy, GCF admin robot. What's that about? What is that service account? And let me tell you, it took a minute. And if I look for VPC Service Controls error with my function, I'll explain you what that other service account is about. So let's run it for 7 days ago. I tested it last time a few days ago. And we see loads of errors, because obviously that's what happens. The functioning invocations, etc. And then if we go into one of the errors, no, that is build fail. That's not what we want. We want something else. Oh, we want something that actually says VPC service control, don't we? So what we're looking here, we see like the IAM errors and the function invocations themselves. We can expand them and expand the fields and see the errors. But what I'm really looking for is a VPC service controls error from when the function ran and I didn't have those service accounts inside my access level. Right. Maybe this? Nope. Right, 7th of February is about the time I know that I have tried this. Well, the demo gods are not on my side today. However, I can still show you the principles. The principle of it is, if you expand the fields of your log of VPC Service Controls error, you will be able to see the proto payload here. You expand that and you have the authentication info. You expand that, you see the principal email that is accessing your project and your resources. When you see that principal email and when you see some request metadata, depending on where it came from, depending on where the error came from, you will be able to see the IP address of the request. And those are the two things that you want to look at when you're looking for explanations on why it did not work. Because the IP address and the principal email are the two things that you will want to include or exclude from your service perimeter, right? You will want to allow that email, or you will want to allow that IP address if that's static and you know that it happens, right? So that's how you kind of can look through the requests and look what happened, and maybe then go back to your Terraform or whatever and look at your access levels and see, oh, is this service account allowed? Why did this request fail? What happened? Maybe the person wasn't on VPN. Maybe their laptop bugged, or for example, Linux machines, sometimes even on VPN, they don't take the IPv4 address of the VPN, they do it by an IPv6. You haven't allowed the IPv6 address, it didn't work. So that's how you can really go into it and see. But we wanted to see whether the Cloud Function has run successfully. So let's remove all this, and last 15 minutes, we'll look in the logs, and we will actually see that there is function execution started, demo while is the expected file, function completed. So when we uploaded the file, the function has run successfully. When we did this, that's what the function was looking for, and it has run because we have allowed its runtime service accounts to access the files in the storage bucket, which is within the service perimeter. And this mysterious service account is what is running under the hood and assuming your own custom service account. Very bizarre, but if you do run into these errors and you look into the authentication info of the request, you can then see that that's what it is calling, and that's what it's running as. And you can add them into your access level. So to recap, you will need project number and project ID. All of the robot service accounts, like the Google specific, Google internal service accounts, they are based on your project's number. And I'm saying that this is based on project number and the project's ID, because if you want to automate the setup, let's say you have a component that deploys the service perimeter and the access levels for the entire organization, and then you want to enable Cloud Functions in some of the projects, you want to be able to automatically deploy these access levels and automatically enable the Cloud Functions to be built and deployed and run. So if you stick to a standardized naming of your service accounts, and one thing that we actually thought about to make it really seamless is to have a custom service account per project. That way, the attack surface is still limited to what you assign to this service account compared to the default compute account. But you have a standard service account name at project id.serviceaccount.com, and you can really automate the whole entire setup. I explain how to do this in Terraform in an article on Medium. You can find it either by the name of this talk or by this link. And you can find me on Twitter and LinkedIn, and Babylon Health has a technical blog where we describe all the awesome things that we do. I'm open for questions.
Wonderful. Excellent. Thank you, Natalie. Hi, Foxy. Fantastic. Excellent demo, excellent presentation. Thank you. Yeah, anybody else got any questions for Natalie? Just stick them in the chat. We've got one from G. Apologies if I said that wrong. Who's asking if there's an additional cost involved in setting the restrictive parameters.
No.
No.
There isn't. Unless there is one particular setting that is now only included for customers of their specific workspace thing. We don't use it. We use allowing user service accounts and IP addresses, and that comes just for free.
Okay, cool. And the follow-on from that is it looks like that's kind of the equivalent of having a private subnet and a service like S3 with a private endpoint. Is it that sort of thing, or is it completely different to that?
It is similar, but it goes beyond that. To have a VPC endpoint, you need a VPC. So your kind of VPC free service such as S3 can have a private endpoint within your VPC. With Google, you don't need to have a network. Pretty much none of our projects have network except those that run GKE and Cloud Composer. So where we consume only APIs and only cloud services that do not need a network, we just put them into a perimeter and they are protected by default without any additional without setting up an additional VPC endpoint in every single project, etc., etc.
Cool, excellent, thank you. Phil, you've got a question. Do you want to come off mute and ask the question?
Yeah, so I was going to ask, what do you mainly use VPC Service Controls for? So is it mainly to stop humans or people accessing the APIs from the public internet? Like, is it mainly IP-based restrictions, or is there some other reason, or why are you using VPC Service Controls?
So mainly, yes, to stop access from the internet. We are a healthcare company. We need to take a really good care that we protect all data, even non-medical data, really well. So we do mainly, okay, so a couple of things. People on VPN, so Babylon internal employees, can access resources. If you're not on VPN, you're not going to be able to access it. Second thing, we set up tunnels, VPN tunnels between AWS, EKS clusters, and GCP to pour data from EKS cluster, Amazon Kubernetes clusters, AWS Kubernetes clusters into GCP. So we know that we trust, and for instance, that allows us to set up the infrastructure in a way that only production can access production on both sides. So you physically cannot mix the data up unless you go and then do it in GCP if you're admin. And like things like Cloud Composer runs in a central location, and it can access different perimeters and so on.
Cool, thanks.
Brilliant. Okay, well, yeah, that's brilliant. Thank you very much, Natalie. Again, if everyone wants to come off mute, and we'll try the round of applause, see how that happens. Thank you very much. Got a couple of Daleks on there. Brilliant. That's fantastic.
Nice.
Thank you so much, Natalie. Thank you for answering the questions as well. So yeah, we're about done now. So just remains for me to wrap up and say thank you to Phil for a brilliant introduction to GCP, which segued quite nicely into Natalie's talk about the cloud functions and how they can misbehave. Yeah, brilliant stuff. It's opened my eyes a lot. Having accidentally had a very AWS blinkered view of the world until recently. So yeah, I hope you've enjoyed it as well. I hope it's been useful to everybody out there. So yeah, I'd say thank you to everyone for coming. David's background, incidentally, Dominic, is from 2001, Space Odyssey. So yeah, thank you to everyone for coming. I hope you enjoyed it. Please do give us some any feedback you want to give, good or bad. If you don't like my t-shirt, that's fine. But especially if you want to speak, we might be coming after some people who we see on the call. Glenn Wilson, naming their names for speaker slots. So yeah, we'll be running again. We don't have an agreed date quite yet, but it'll be about this time next month when we run again. So so yeah, if you want to speak, John Guerrero, how many shots have you had due to mentions of Terraform? Are you still conscious?
I've actually just had my first one, and it's non-alcoholic. It's sad, but I got to get through this stuff. It's dry January remnants, I guess.
That's very noble of you. Very, very noble.
Yeah. Tomorrow I'll cut loose, though. We'll chat. Yeah.
But January is already 11 days away.
That's true. I know. You know what's funny about non-alcoholic alcohol is that it actually goes off if you leave it. So
Yeah.
I don't get that, right? Anyway, cheers. Thank you. Really interesting.
Cheers, John. Okay, so yeah, I'll leave the line open. I can stay for a few minutes afterwards. We'll have a mini social just to say hello. Or there's still some chat going on about AWS and IAM and VPCs and things. So yeah, hopefully Natalie's asking all your questions. Sorry, answering all your questions well. But yeah, it just remains for me to say thank you to everyone for coming. You had a really good turnout tonight, so I'm very pleased with that. 2 excellent talks. So we'll see you again next month. But apart from that, it's a good night from all of us. So thank you.
Yeah, thank you for coming.
Thanks, guys. Thank you.
All right. Nice meeting everybody.
Thank you.
There was a very loud microphone.
Yeah, it's almost like a certain person at work that has not found the gain button on his microphone yet.
No, or maybe working next to heavy machinery.
Sorry, I have a question for you guys. I don't know, everybody's leaving.
Yeah, go for it.
Go for it, John. Yeah.
Okay, yeah, hi everyone. This was my first time here. I just stumbled into this group and I decided to join because I'm kind of transitioning to